Okay, so today we're going to talk about geometric sequences. So last time we talked about arithmetic. This time we're going to switch to geometric so that I can have you do the fun project that I like to have everybody do. This book actually puts everything in a different order, but I like that project, so I want y'all to do it. So today we're going to talk about geometric sequences. How many of you know what an exponential function is? I don't remember if we've covered this yet or not. Okay, so an exponential function is any function where the exponent, the variable is in the exponent. So the unknown is up in the exponent. Okay. So one of the simplest exponential functions is f of x equals 2 to the x. So our variable, our x, is in the exponent. That's what makes it an exponential function. And geometric sequences are exponential functions. Okay. So what are exponents? Okay, so it's timing by what number?
Like, not actually doing it, it's like it's difficult to explain exponents.
Okay, what's multiplication? What are we doing when we multiply?
Adding a number.
We're doing repeated addition. We're adding the same number every time. So what exponents are? Exponents are repeated multiplication. So we're multiplying by the same number every time. So when we're trying to figure out, oh, that's not what I wanted to do. Let's slideshow it. Okay. So when we're looking to determine if a sequence is geometric, we're looking to see if it's multiplied by the same number every time. But first, we have to determine, is that better? Did you say better though? So in order to determine if a sequence is geometric, we have to rule out that it's arithmetic first. Okay, so we're going to rule out whether or not it's arithmetic. We're going to rule out if it's a quadratic. And then if neither one of those is true, then we're going to start looking to see if it's geometric. Just because finding the geometric ratio is a little more complicated than finding the first and second difference. Okay. So we're going to look at the sequence 3, 2, 4/3, 8/9, and 16/27. Then it continues on forever. So that's the example that we're going to use as we explore this today. So let's think back to last time. Last time we did the first differences, right? So we took a value that came out, one of our y values, and subtracted the one before it. So I already did that for this one. Is that all the same?
No.
No. So is it an arithmetic sequence?
No.
No. So when you find the second difference, it will tell you if it's a quadratic function. So I did those. Are those all the same?
No. No.
No.
Wait, how do you find the second difference?
You simply take the difference of the first difference. I know that sounds like really, really wonky, right? But we took these ones and we subtracted the one before it. So this one, we take this one and subtract this one. And then this one and subtract this one. So we're just doing the exact same thing, just one more step up. Does that make sense? Okay, and we'll play with those a bit later. Those are really hard to write, so we don't really teach you how to write those in secondary one. Teach you how to do it with a calculator in sec 2 though. So when that doesn't work, because those aren't the same, now we're going to look for ratios. How do you find a ratio? What is a ratio? This is like reaching back to 7th grade math brains here.
Like a fraction.
It is a fraction, but it is a fraction that is created.
Like for every 4 cups of water, like 2 cups of water, right?
Yes, exactly. So what we're doing is we're looking to compare two numbers to each other. and find out if they're divisible or what they would divide down, simplify to. So we will take our second number and divide it by our first. Okay, so 2 divided by 3 gives me 2/3. Then I'm gonna take 4/3 and divide it by 2. So we're gonna practice our dividing fraction skills today. How many of you remember how to do that? Gotta-
Yeah, I do. You just put it on
Okay.
the two.
So let's review dividing fractions really quick, because that's gonna be important.
I don't remember how to do that.
Alright, so if I have 4/3 and I am dividing it by 2, then what you do is you flip it
So it's 2 divided by 4.
and multiply it. So this looks like a whole number. How can I turn a whole number into a fraction?
Put a 1 under it.
You put a 1 under it. So I'm gonna go ahead and put in that 1. Then I like to draw this nice little curly Q right here to indicate that I'm gonna flip it over. And I'm gonna multiply. How do you multiply fractions? Anybody have their planner on them? The one the school gave you? There's a cheat sheet in there for fractions. There are cheat sheets in your planner. Did you not know that?
Oh, hey, so, 4 and 2 are both divisible by 2.
Okay, that is true.
There, I have that, 1 over 1, we multiply, they put it 2/3.
If you grab your planner, you thumb through the front, right behind the handbook part. There's a whole bunch of cheat sheets, right? It says this planner belongs to. And then you get a cheat sheet for conversions, measurement conversions. You get a cheat sheet for English class. Cheat sheet for punctuation, the Bill of Rights for Gov and Civ. I'm pretty sure there's maps in here for geography. Yep, maps for geography. Math resources. So right after your maps for geography, you've got math resources. It's got a multiplication table, some of the common symbols used in math, the order of operations, all the polygons, the area of planes of shapes, formulas, and a little working with fractions box. So if you ever forget, there's cheat sheets in your planner. They're provided by the school. So with multiplication, you just go straight across. You multiply the tops together, you multiply the bottoms together. So 4 times 1 is,
4
and 2 times 3. Okay, is that as simple as it can go?
No.
No, how can it go simpler? What can we do?
You didn't divide all that by 2.
Divide them both by 2, and what would we get?
2/3.
2/3. So, once again, we get a 2/3, okay? And then we would do 8/9 divided by 4/3. You're gonna do that whole flip and multiply thing again. And I will encourage you to practice that, because if you don't put these into the calculator just right, you're gonna get the wrong answer. Okay, because it will take every fraction sign as a division sign, and it will just divide all your numbers in a row instead of dividing fraction by fraction. So 8/9 divided by 4/3 is 2/3. And 16/27 divided by 8/9 is also 2/3. So if you do that division and they're all the same, then you have a geometric sequence.
What if
Okay.
they're not always?
Then it's not a geometric sequence, and you're gonna tell me, this is not actually a sequence, it's just a list of numbers. Alright, so if the first difference, second difference, and ratios don't match up, then as far as you're concerned at this point in your math career, it is not a sequence. It's just a list. Because sequences should have a pattern to them. I don't remember if this chart is on the next page. We got some people writing it down. I just don't remember if I posted this on Canvas yet. If not, it'll be done before the end of class, because Jeremy needs to be able to do it at home. was working till 10:30 last night and I was so tired, I don't remember what I did and what I didn't do. Y'all wanna be a teacher now, right? Wanna come home to school every day and tell you I worked till 10:30 the night before? Okay, so just like with arithmetic sequences, we have a magic formula that we can put stuff into. Okay? We like magic formulas, right? It makes life easy. So we're gonna have an a sub n. Anybody remember what n is from last time?
The numbers.
This is the case. Right? But a sub n is what?
Sequence.
The term of the sequence. Right? So that's the output. It's the number that comes out. N is the number that goes in. R is that ratio that we found. Okay, and anybody remember what a sub n minus 1 is? It is the term before the one we're looking for. So remember last time we talked about if you were looking for the 100th case, you would want to add the same number 100 times. That gets really tedious and obnoxious. This is a recursive formula, so it depends on the term before. So if I wanted to find term 50, I'd have to find term 49 first. Right? So it's great if it's just the next 1 or 2 terms. Once you get much further than that, it's a lot of tedious math that none of us want to do. Right? Lots of periods, right? So we'll wait a second, everybody get it written down. And this is an important one to have in your notes. Let's see if Jeremy's here yet. Don't see him. Okay, everybody got this one? Are we ready? Okay, so next we've got the explicit formula. Does anybody remember what an explicit formula is?
It's different there.
It is different. Otherwise, it wouldn't have a different name.
But
A little bit.
I had an exponent.
It does have an exponent. But the explicit formula is the formula that puts it in terms of n. You don't have to have every number in the sequence first. Okay, so our a sub n is still the term that we're looking for, right? And Marie, did you stop by the office and get a slip? Leave this on my desk. No, okay. N is same as with the recursive. It's the case. What is a sub 1?
It's a very special thing. Is it a special thing?
If n is the case number, What case is this?
First one.
It's the first one. It's the first term of the sequence. Okay, and our R was interesting thing for my brain. Is that common ratio? Okay, so since we have to have some terms of our sequence to figure out if it's a sequence, we have that A1. So it becomes a plug and play. You guys know what that means? Do they even use that term anymore?
I had a bunch of fun in places when I was little. They're my favorite.
Yeah, it's a little bit different than the initial meaning. When it first came out, it was things that you could hook up to your computer and not have to download tons of software before you could use it. So like if you had a printer that you could just plug in, your computer would automatically recognize it and work, then it was a plug and play. So all you have to do is plug your numbers in and you can use it. So just like last time, this is very much if you can find the common ratio, you can just plug those numbers into the formula, just like last time. So just like last time, it's not going to be a terribly difficult assignment. But let's practice this just a little bit first. Okay, so this is what was on the other slide, so we already did this math. Right, I just put it in again. Okay, this is not so bad, it's not so bad. We did this before, this was already done. Okay, except I'm gonna show you why it's not as scary as it looks. It looks scary, but how would we find the next number in our sequence? How did I find 32 over 81? Times it by what? The top got times by 2.
Divide 32 by 1.
All I did was I took this number right here and I multiplied it by 2/3. Right, which is what our recursive formula says. Our recursive formula says take 2/3. Right, so this is our R. Is that 2/3 that we found? So we just plug it in. So much like an R. Okay, that's better. Okay, so we just plug in our R right there and that's it. That's all we have to do for our recursive formula. Okay, so this looked scary, right? All I did was take this 2/3, plug it in where my R is in my magic formula. So if I wrote down my magic formula, write down the magic formula. You have the magic formula, you just pop the numbers in. Okay, and then I said, okay, if I want to find a sub 7, if I want to find the 7th case, what do I do? Got my 2/3, a n minus 1, 7 minus 1 is 6, right? So I need 6 to go in. So when I plugged in my 6, multiplied them together,
64.
and I get 64.
Haven't seen a regular division sign forever.
I know, I was like, I'm gonna have to use some regular division signs in here or else this is gonna get real confusing real fast. Too many fraction signs in one problem will make people's heads start spinning around like in the movies, you know? Okay, so go grab a calculator because you're gonna help me find 8. Wrong place for that. My brain really wants to fill in the chart. Okay, so let's use the recursive. And actually, let's not. Let's use the explicit. Let's use the explicit to find case 8. I did case 7 right here with the explicit. So with the explicit, I take my A1. What's my A1? 3. Because when I put in 1, I get out 3. That's where this 3 came from. Okay, and I took it. Can't see, I'm in the way. And I put it right there in my magic formula. Right? And then I took my R and I put it right there. So I took numbers I already have and I just plug them in. Just replace the letters in the magic formula. Okay. Now, if I want to find A sub 8, my 3 doesn't change, my 2/3 doesn't change. N minus 1.
7.
7. Because 8 minus 1 is 7. Can you put that in a calculator?
Yes.
You can. You're not sure how to get that exponent because it's not a 2. It's the little caret symbol. I don't know why that's called the caret symbol. It does not look anything like a carrot.
Wait, just
But
3 and
so you'll go 3 times. Put the 2/3 in parentheses when you're putting it in a calculator. It guarantees that it stays a fraction. And they do that first. And it also makes sure they take the entire 2/3 up to 7 instead of just the 3. I think how the calculator would do it.
how do you do the exponent on this calculator?
So which one is that? That one is scientific. Let's see where the button is on that one.
I think this is
Yep, that button right there. Yep. There.
it is very scary. Oh wow, that's an interesting.
Okay, it probably came out as a decimal, right?
Very big one.
If you have a graphing calculator, you hit math, enter, enter. If you have the scientific, you hit the N over D button, and it will turn it into a fraction. So what did it say it was? In my head, I know the top is going to be 128. The 64 times 2 is 128.
We did 28 over 729.
That sounds about right. How did it come out the right way? Let's see how it changes your end. Oh, you might have to push, no, it's second and then this table button. I don't use that one very much. Way more familiar with the graphics. All right, so do we see that we're just taking our numbers from our table and we're plugging them in? Okay, don't let it freak you out. It's the same thing you did last time. Except for there's some division involved this time. I don't remember if I did any more slides or if that was the last one. Oh, okay, look. So for today's assignment, I'm going to give you a worksheet to practice the same thing we did last time. But you are most definitely going to have extra time. So if you do, if you did finish last time's assignment, do that first. But then I want you to practice IXL skill 5W7. It will just let me know how much of this you're getting and what maybe I need to do some more of for next time. Okay. Make sense?
Can you go back one slide?
Yes, I can. Okay. So just like last time, we'll do number one together. We're looking to do the same three things as last time. Determine if it's geometric. Find the common ratio or R. And then instead of having you do the next three terms, I just have you find the explicit and recursive formulas. And then use those to find term number 8.
I didn't hear
So
you.
technically, it's actually a little bit less than last time. So less than last time's good, right? You just have to find one additional term instead of 3. All right, so let's look at number 1. Hold on. Let's let Milo finish writing down what's on the board first. All right. I'm gonna turn off the projector for a minute so that our picture is not in the way. Maybe, there we go. All right, so before we do this, let's write down our 2 magic formulas. Okay, what was our recursive? We always start with a sub n equals.
N equals R parentheses A and this N minus N.
Okay. Easy enough, right? Just plugging in R. And our explicit. Starts out the same, a sub n. First term. Times R to the n minus 1. Okay, so these are our geometric ones. All right, so there's our magic formulas. You don't want to lose those. Want to keep those handy. So let's look at number 1. I don't know about you, but I can tell just by looking at that, there is 0 chance that's an arithmetic sequence,
Yeah.
right? There is no way that has the same first.
Because I mean, 3 times 6 is 18, but 18 times 6 is not 108.
Are you sure? You might want to check that. But I'm going to create a table because I like the organization of a table. It helps my brain process things. Gives me 4, and I need to find 8. So I've got a -3, -18, a -108, and a -648. X. That's my Y. And really, because it's just asking you on this assignment to determine if it is a geometric or not, you don't really need to find the first and second differences, right? We don't care if it's an arithmetic or a quadratic today. We only care if it's geometric. So we just want the ratio. Okay, so let's remember how I find that. How do I find that? I take my second number and divide it by my number before it, right? So -18 divided by -3 gives me 6. Okay, so now to find the ratio of the next one, I'm going to take it and divide it by the number before it. I'm gonna throw that in the calculator and tell me what you get.
6.
It's 6. Looking promising so far.
Yes, 6.
So what do I do on the last one? I say it louder.
648 divided by 5. Negative
What do I get?
6.
Okay, so is it a geometric sequence?
No. Yes. I guess.
If our R's are all the same, the answer is yes.
It's just like yesterday's percent.
Yep, only this time we're looking division instead of subtraction. All right, so yes, so now we're looking for our recursive formula. Okay, for demonstration purposes, I'm gonna copy my magic formula straight over. And then just replace the ones I need to replace. What do I need to replace in this?
R.
R. Anything else?
N.
No, I don't need to replace because I want this to be generic, right? What is my R?
Ratio 3.
6. That's all I have to do. That one's done. Okay. The last time y'all ever thought it really hard, are we gonna overthink it a little bit less today?
Yeah.
Same idea. Okay, explicit formula, same thing. I'm gonna copy my magic formula right over. Okay, what am I gonna replace this time?
The A1 and the R.
Okay, so what is my A1?
Negative 3.
Negative 3. And I just got that from right here. Okay, what is my R?
6.
And have my two formulas. Now, the last thing it asks me to do, it says the 8th term, right?
Yeah. The 8.
Yeah, find the 8th term. All right, so I want to find A sub 8. Which one of those two formulas do y'all want to use? We can do either one.
Explicit.
Explicit. Explicit, why do you want to do explicit?
Because it is further away.
Yeah, because then we don't have to do 5, 6, 7, right? We can go straight to 8. Nice. So all I have to do, use the formula. What is n minus 1?
7.
7, because it's just this number minus 1. And then I'm gonna stick that in my calculator. Or you guys are gonna stick it in your calculator. Tell me what comes out. Not you, Luke. Somebody else. Heard your voice almost every question.
Negative, very, very big number.
Like 6 to the 7th is gonna be a big number.
I can read you the numbers, but I couldn't tell you the
Go
actual
for it.
word.
That's all right.
839808.
839,800.
Correct.
There we go.
You have to put that in your final.
Yeah, you have to do a sub 8 for each problem. Okay, so this is your full answer. It's gonna be on your paper for each problem.
We have to go do both formulas.
But it's just replacing your R and your A with 1, so it's not hard. It's just good. I have you do it, kind of repeat it that many times, so it creates a new, what it does, every time you repeat something, it creates a pathway in your brain. And the more you repeat it, the stronger that pathway becomes. So if I have you do it 10 times, it's gonna solidify that pathway for you. If I make you do it 20 or 30, it'll be even more, but then you guys will hate me forever and it'll just become busy work. Yep, so then you want number 2. Need to make that smaller. Put this over here. And stop recording.